when naming polygons, especially quadrilaterals, when naming special types of quadrilaterals, something that might help you to determine what type it is the slope. And so that's what we're going to talk about today. So we can use slope in coordinate geometry, which is just geometry in a coordinate plane, to help us identify and name the type of quadrilateral we see. Your target then is we're going to learn how to find the slope of the line. We're also going to identify polygons in a coordinate plane using slope. So what do you think of when you hear the word slope? I think of like the ski slopes or snowboarding. Going to Seven Springs or Hidden Valley or somewhere and skiing. A slope down the slope would be, down the side of the mountain. It would be steep. It would be slanted. That's what we're talking about here. Slope is a number that describes how steep a line is. So it describes the steepness. And slope can be described or can be found by finding how much the line changes vertically, or the vertical change, divided by the horizontal change. A simpler way of saying this is that slope is rise over run. So we have 4 different types of slope, and when you look at these graphs, I think about a little guy walking on these graphs. So this first line, we could walk on this graph. If we were walking on this line, we would be walking uphill. This is a positive slope. It's pointing towards the up or towards the positives on the right side of the graph. So it slants up to the right. If we were walking on this hill, we'd be walking downhill, or it's a negative slope. Negative numbers help us represent going down. These numbers all the way down here are all negatives, and it slants down towards the right. So you read a graph from left to right. You would read a graph skimming over this way, and as we move to the right, that one's increasing. As we move to the right, this graph is decreasing. Then we have these 2 cases over here, and I always have students that mix them up. So here's the way I think about it. Again, can you stand on the line? Can you stand on a mountain or on a slope like this? Versus can you stand on a mountain or a slope like this? Can you do both of those? Well, you can definitely stand on this. This would be like you're walking on flat ground. What is the slope or the steepness of your line? The ground right here has no steepness, right? It's flat. Or the steepness is 0. The slope is 0 then. Slope of all horizontal lines are 0. Versus this other type, can we stand on the edge of a mountain like this? No, right? I mean, if there was a cliff and you fell off, you wouldn't be walking down the side of the mountain, right? So this is impossible to do. This would be undefined. We can't define how steepness that line is because it's straight up and down. So all vertical lines have undefined slopes. And I'll show you later on why it's undefined mathematically. But remember slope as rise over run. How much do you rise over how much do you run? So let's practice identifying these slopes and then also finding slopes. In example 1, I want you to determine if the slope of each line is positive, negative, 0, or undefined, and then find the slope of each line. Let's identify the types first. When you're looking at line AB, AB is over here. This line slants towards the up on the right side, towards the positive, so it is a positive slope. What about when you're looking at B? J, F, J, and here's F. This line vertically, can you walk on this mountain? Definitely not. This would be undefined. All vertical lines have undefined slopes. C, CD. CD is right here. This slope would be negative because it's slanting down towards the right. Line GH is a horizontal line, so that slope, if you were walking on that ground, is 0. Line EJ, positive. And line DH, undefined again. Remember, vertical is undefined, horizontal is 0, because you can walk on a ground like this, you can't walk on a ground like this. So Whenever the slope is undefined or 0, that is the slope. That is the number of the slope, okay? The slope is undefined on line JF, and the slope is 0 on GH, line GH. When it's positive or negative, though, we can actually find what number value the slope has. And the way we're going to do this is by counting the rise over the run. So let's look at line AB. Line AB, find 2 points on your line that are right on the grid marks, and they give you these points here. So we are using these points because the grid lines intersect them right at that point. So this is perfect. From one point to the other point, count your rise over your run. I'm going to start with A. From A, I would have to rise how many units to get up on the level of where B is? Well, 1, 2, 3, 4, 5. It would be up 5, so that's a positive 5. And then when I'm up 5, how many do I have to run to get to B? 1, 2, and it's towards the positives, so it's a positive 2. So this slope of AB would be rise over run, or 5 over 2. Now I do want to show you, you can also count it from the other points, starting with B and going to A. Let's try this. If we started with B, how many would I rise to get to A? Well, I would actually have to fall, so this would be what type of number? Negative over here. I would fall till I get on the line with A. 1, 2, 3, 4, 5. It'd be a negative 5. But then watch, from this point I would have to run to a negative 2 to get A. So that fraction of rise over run would be negative 5 over negative 2. We wouldn't leave that, guys. Let's simplify those negatives. A negative divided by a negative is a positive. So you can see here, it doesn't matter from which vertex you start and which vertex you go to, you will end up with the same slope. Undefined for B is our actual slope, so we're going to leave that. C has a negative slope. Let's actually find what the negative slope is. Highlight your 2 points. You have D and C. Pick one to start at. I personally like to always start on the point closer to the left side of the graph. So I'm going to start with D. How many do you rise? How many do you run? D, I would rise, but I'm actually going down. So what type of number would that be? Negative. 1, 2. And then from that point, how many am I running? I'm running towards the positive numbers, and I'm running a positive 2. Set up your fraction now. Rise over run. So the negative slope for C would be negative 2 over positive 2. Let's not leave it like that, guys. Let's simplify that. Negative 2 divided by 2 would be a negative 1, or you could say negative 1 over 1. The slope then of line CD is negative 1. For D, the slope is 0, so we don't have to do any work there. For for F, EJ. Line EJ is right here. Count your rise over your run. I'm going to start with E. I'm going to erase some of my other work too so that you can see this more clearly. From E, I'm going up, so it's a positive. 1, 2, 3, 4, 5. And I'm running positive 2. So my slope is rise over run, or 5 over 2. I would leave it as a fraction and not as a decimal because we like to see the slope as rise over run. And the last one, G, the slope is undefined. There's no work to show there. So then using that same graph, in example 2, I want you to look at the picture in graph 1, or in example 1, and name a set of parallel lines and name a set of perpendicular lines. Do you notice anything special about their slopes? Well, when you look at this graph, name one set of parallel lines. There's actually 2 in the picture, right? Line AB, and you make sure you put that line symbol over top, is parallel to line JE. You also have that line JF is parallel to line HD. So when you look at their slopes, do you notice anything that they have in common? Line AB slope was 5/2, and line JE or EJ slope was also 5/2. Interesting. And JF had an undefined slope, and HD or DH also had an undefined slope. What do you think parallel lines always have, guys? Parallel lines are always going to have the same slope. They have the same steepness, which is how they never intersect each other. If the steepness weren't the same, eventually they would run into each other. Perfect. What about a set of perpendicular lines? Well, I see that JF is perpendicular to GH. And I also see that HD is perpendicular to GH. In both of these cases, you have an undefined slope paired with a zero slope, right? GH has a slope of 0, and the lines that are perpendicular to that slope are undefined slopes, HD and JF. So perpendicular lines, all vertical and all horizontal lines will be perpendicular to each other. They're always going to create a 90-degree angle. So all undefined slopes, their lines are paired with zero slopes, and they're going to be perpendicular. There's something else too, but it's hard to see in that example. So turn the page. We know that parallel lines have equal slopes. Perpendicular lines have opposite reciprocal slopes, and I'm going to give you a couple examples. So write that down. And we also have in here that all horizontal lines and all are perpendicular to all vertical lines. So an example of a slope that would be perpendicular, opposite reciprocals. Opposite means negative versus positive, and reciprocal means flip the fraction. Okay? So if my slope of 2 is on a line, it would be perpendicular to a line with a slope of what? Well, what's the opposite of 2? Negative 2. And flip that over. Negative 2 as a fraction would be over 1, so flip it. You actually reverse them. It would be 1 over 2, and that's a negative. These two slopes would be perpendicular. They're opposites of each other, and they're reciprocals. Let me give you another one. If I said you had a slope of 3 halves, the perpendicular slope would be the flip of that, flip it over, and make it the opposite sign. Flipping this would give me 2/3, opposite sign would give me negative 2/3. So if you start with a positive slope, your perpendicular slope is going to be negative. If you start with a negative slope, your perpendicular slope is going to be positive, and you flip it. Try example 3 then, and then press play to go over it. So in example 3, hopefully you saw what the slope of line Z is going to be negative 3 halves because it's perpendicular to line M. And the slope of line Y looks parallel to line M, so it's going to have the same slope, which would be 2/3. Last example then, we can use this idea of slopes to classify or to name, the polygons that we saw yesterday, the special quadrilaterals. So a quadrilateral has the vertices E, F, G, H. Use your knowledge of slopes to name it. So let's graph this first. -1, 6 would be point E. 5, 6 is F. 3, 4 is G. And -3, 4 is H. So let's graph this quadrilateral. We can see that it's a quadrilateral because it has 4 sides. Let's check the slopes, and then maybe we can classify it. You can make a prediction of what it is on how it looks, but we always want to check the slope to make sure it is what you think it is. So what would be the slopes of all these segments? What's the slope of EF and HG? Well, EF and HG are both horizontal lines, so their slope is 0. What's the slope of EH and FG? 1, 2, 1, 2, 2 over 2, which is really 1. Same thing over here, up 2, run 2, 2 divided by 2, which can be reduced to 1 or 1 over 1. So these have the same slopes. What can you classify this as? Opposite sides have the same slope, which means they are parallel. So this would be a parallelogram. Are the slopes opposite reciprocals? Because if they are, it could also be a square if they're perpendicular. 0 and 1, are those opposite reciprocals? No. So this is not a square, it's not a rectangle, it is a quadrilateral, it is a parallelogram.